Oh, yo, yo, yo. Howdy, 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 ho, lads. Yo, Shriram. Can you hear me? Howdy, Rover. Morning, mate. How you guys doing? Oh, I'll remove this Roblox one. Oh, Shriram, quick thing. If you go on the Roblox one, we started the sponsorship for Roblox. I'll send you the link. You just have to download it, create a new account, and play it for 15 minutes on a new phone, right? I believe, or whatever. And then, like, it's $4 per person. Like, sponsors pay. Yeah, let's go networking. Yeah. I'll just quickly share the link. Okay. I'm just going to quickly share the link. I'm going to remove this stupid pop-up, but one second, I'll show you guys something quickly. Okay, here is the link. Go download from here and just play for 15 minutes. That's all. I think it was Wrench downloaded it. I downloaded it and played for 15 minutes. We need more lads for this. Okay. With that out of the way, let's focus on our main bread and butter. Networking Essential, a premium room from TryHackMe. Those. Is that Wrench? Feels like Wrench. I think they should be fine. Howdy. Doze. Who is Doze? It's Wrench, right? Doze 111. I don't think premium rooms get me. Like, Hack the Box doesn't like if I do things unless until they're retired. So, YRUG. Holy. Okay. Okay, but let's get started with networking essentials. If things go wrong, if I get a copyright or strike on my system, I'll just remove it. But for now, I think we should be fine. We'll get it done at least once, right? Okay. So, networking essentials, explore networking protocols from automatic configuration to routing packets to the destination. So, from automatic configuration to the routing packets to the destination. Okay. Introduction. Yeah, probably not, right? TryHackMe is lenient in that case. Hack the Box is not. I already have one strike from them. I have to talk to them. I think I still have the strike. For one AI thing I did. AI one. Content, community. Why you guys don't comment? Other guys don't comment. I don't know where to see it. I believe, yeah, here. There is one copyright strike, so I have to talk to him, this guy, and I think hopefully he removes it. So, have you ever wondered how your computer can dynamically configure its network settings when you turn it on or connect it to a new network, basically a new Wi-Fi or a new system through Ethernet, like through internet to internet through Ethernet and stuff like that, or just like your phone whenever you want to connect through cellular and stuff. What's up, bro? Have you ever wanted to know how many devices and countries your packets pass through before reaching their destination? Are you curious how all your home devices can access the internet even though your ISP gives you only a single IP address? Oh, India got its own server. Nice. That's awesome. If you want to know the answers to these questions, among others, then this room is for you. This room is the second room in the series of 4 rooms about computer networking. The networking concepts which we covered, networking essential, this one, core protocols is the next one, and secure protocols. Learning prerequisites. To benefit from this room, we recommend that you know the following: ISO OSI model and layers, TCP IP model and layers, Ethernet IP, and the TCP protocols. Yeah. In other words, starting this room after networking concepts is the recommended approach. Learning objectives. The objective of this room is to teach you about various standard protocols and technologies that glue things together. So one of the big ones, right? These are the ones actually you will use, but first one is actually very fun. Dynamic host configuration protocol. This is the one you in your subnet when you are talking on your phone or connecting through Wi-Fi. This is the one used to get you a private subnet IP address inside your house when you want to connect your device to the system. Oh, you download a game? Thanks, mate. Like just keep it on for I think for 15 minutes. Focus. That will count, I believe. Address resolution protocol. This is very similar to if you are actually want to set up your home lab, if you want to see what addresses there are, what all devices that are connected, you will be able to see. Network address translation. This one I forgot. I believe it's helping find the IP addresses or something. ICMP. This one is useful in like finding, like if you are able to reach a particular server or if you are able to like see how the packet is moving. So ping to reach the server, trace out how the packet is moving. Let's get started. This one will be a bit smaller than previous one, so that's good. You went to your favorite coffee shop, grabbed your favorite hot drink, and opened your laptop. Your laptop connected to the shop's Wi Fi and automatically configured the network. So, you could now work on a new TryHackMe room. You didn't take a single IP address, yet your device is all set up. Let's see how it happened. Let me just quickly open the Obsidian as well so we can draw. Start the machine. Is there machine in this one? There is no machine in this one, mate. No machine in this one. Yeah, not much. There will be suffering, just not much. Bro, look at this. Palantir is down even 5 more percent. People are suffering anyways. It's down from its high. Like I think it's down like 10 plus percent. People are suffering. Don't worry. If not me, somebody is suffering. That's for sure. So you went to your favorite coffee shop, right? I happy. Yeah, I think a lot of people are like suffering, but a bunch of them are greedy as well. Um, so yeah, as we were talking, your laptop connected to shop's Wi-Fi network and configured the networking configuration automatically without getting a single IP address. You are able to still connect to the system. So let's say this is our coffee shop. coffee shop. And you are here with your laptop. I have no idea how to draw a laptop. This is your laptop here. I don't know why I draw like that. Okay. Whenever we want to access a network, at the very least, we need to configure the following things: IP address along with the subnet mask, router or the gateway, and the DNS server. Let's break things down, right? What if each single one of them does? So IP address, I believe, like as you guys know, this is your address you need whenever you are sending or receiving packets. You need this address so that you can talk. So packets can go somewhere and you can come. They can come to a particular address. Hi Panda. Router are basically like the roads, because if you are sending packets, things are going right. If you want to send them, there has to be roads, so the packet can go somewhere and bring somewhere, right? DNS server, because you can't remember all the phone numbers, you can't remember the IP addresses. Do you remember google.com, not the IP address of the google.com? So that service. Three main things essential to send or receive packets. Whenever we connect our devices to a new network, the above configurations must be set according to the new network. Manually configuring these settings is a good option, essentially for servers. Servers are now expected to switch networks. Are not expected to switch networks. Sorry, servers are not expected to switch networks. You don't carry your domain controller and connect it to the coffee shop's Wi-Fi. Domain controller is like a very main server in your organization with all the authentications, Azure, Active Directory stuff. However, moreover, other devices need to connect to the servers and expect to find them at specific IP address. So google.com, you will find it at the specific address. Facebook, you will find it at a specific address. Howdy, Panda, howdy. Having an automated way to configure connected devices has many advantages. First, one second. Okay, having an automated way to configure connected devices has many advantages. First, it would save us from manually configuring the network. You don't have to give yourself a IP address. Things can be done automatically, or even protocols, what Wi-Fi protocol to use or security. This is extremely important, essentially for mobile phones. Secondly, it saves us from address conflicts. That is, let's say if you want to give yourself an address in your personal subnet, and by chance you gave yourself the same IP address as the other device, that is what address conflict is. When two devices are configured with the same IP address, imagine two houses, like two neighbors, have the same address. Your packages meant for you will be going there, right? Not so fun. An IP address conflict would prevent the involved hosts from using the network resources. This applies to local resources and the internet. So any network, you think this is going to be the issue, right? The solution lies in using dynamic host configuration protocol, DHCP. DHCP is an application level protocol that relies on UDP. The server listens to the UDP port 67 and the client sends UDP port 68. The server listens on the port 67 and the client, so basically our phones, are sends from 68. Your smartphone and laptop are configured using DHCP by default. DORA, discover, offer, request, acknowledge. I hate the word. DHCP follows 4 steps: discover, offer, request, and acknowledge. Dora the Explorer. Okay. So basically, for servers who wants to give the addresses and stuff are listening at 67, whereas your mobile phones are listening at 68. DHCP follows 4 steps. Okay. DHCP discover, the client broadcasts. What? Dosa BL? Oh, true. I know exactly what you mean. You want more views on Twitch or YouTube? YouTube, mate, please. YouTube, please. I have to like start putting good videos out. DHCP Discover. The client broadcasts a DHCP Discover message sending the local DHCP server if one exists. So, now back to what we have for our coffee shop, right? This is our laptop here. Okay. Why is not... Okay. This is not going the way. Okay, it's fine. It's fine. It's fine. So this is our laptop. Right? Then, let's say inside the coffee shop, the Wi-Fi router is here. So this is our Wi-Fi router, right? This is also the one with the DHCP. So basically, this is our DHCP server, right? The client broadcasts a DHCP discover message seeking for local DHCP server. So this is our server. So our laptop will send a request. This is the first one called DHCP discover. Next is DHCP offer. The server responds with a DHCP offer message with an IP address available for the client to accept. So DHCP server will say, okay, they have like a lot of addresses available, right? Because inside your house you will have like, let's say 10, 20 devices. At the end of the day, server, the router always have like around 100 plus it can handle, or the addresses at least. So it will send back second will be the offer, DHCP offer with the IP address, the internal IP address. Then DHCP request, the client responds, basically our system responds with DHCP request message to indicate that it has accepted the offered IP. Third, DHCP accepted. Fourth, DHCP acknowledge. This server responds with DHCP acknowledge message to confirm that the offered IP address is now assigned to this client. I want a cleaner one. Oh well. Fourth, Rover will probably hate me right now. It's so messy. Okay, fourth is DHCP acknowledge. So first, the laptop who wants to connect, say coffee shop Wi-Fi free. Oh, thank you, mate. Please don't. I request. Oh, just my digital junk. I'm trying to get better. I will become better. Hopefully, I guess maybe I can try. Okay, so we have DHCP Discover, right? In the Discover one, first the laptop, my laptop or my computer or my phone, I try to connect to the coffee shop's address. So coffee shop Wi-Fi, free Wi-Fi, Discover. It will give me an IP address. I will say, okay, I accept the IP address. They say, okay, the IP address is now assigned to you. Right? Simple. Actually, it's not bad. It's simple. It's same as almost TCP. TCP is 3, this one is 4, so it's not that bad comparatively. The following packet captures how the 4 steps explained above. In this example, the client gets the IP address, and you can use, I think, Wireshark. Try to use Wireshark and before connecting to your Wi-Fi, try to use Wireshark. Dude, draw.io, yes, I love it, but it is way more time taking because it's I have to properly get all the images and stuff. This one is auxiliary. I like it because I can draw. So tshark-r DHCP something pcap-n. So I think Wireshark packets is able to looking for just DHCP servers in the pcap file or DHCP protocols. Disconnect and capture. Sure. I'm not doing that, man. I'm not doing that. You should do it at home after this stream. So at time, let me give you guys this. One second, lads. Okay, this should work. KC7 game? Sure. Bro, Sundays is for you guys. Whatever you guys want me to do, I'll do it. Saturdays or Sundays. Okay. So we have this first one. Let's see. This is our number. First packet, second packet, third packet, fourth packet. This is time at T0. T in milliseconds, seconds, right? So IP address 0000 from R1, we are sending to the DHCP network mask, the end one, right? The broadcast server or message or the IP. DHCP protocol. I have no idea what this 342 is. Do you guys know what this 342 or 376 is? It sends a DHCP discover message, transaction ID this. So I believe this is our address, laptop, or let's say, yeah, laptop. This is the router or Wi-Fi router. Then we have the Wi-Fi router again, because it has two. It has a network one, like a network mask one, and a broadcast one. and one its own, right? So this will be router again. Offer, it sends us one with this is the offer. Hey, I have this IP address available. So the laptop says, yes, I accept the IP address through again to the broadcast to the router. And then router says, okay, this address, the one I offered you, this is your now, and I acknowledge. I have no idea what this is. Let's see if this is the way we are thinking is right. In the DHCP packet exchange, we can notice the following. The client starts without any IP network configuration. It only has a MAC address. In the first and third packets, DHCP discover and DHCP request, the client searching for a DHCP server still has no IP network configuration and has not yet used the DHCP server's offered IP address. Therefore, it sends packet from 0000 to 255.255.255. Why 255 is because, first of all, when you, let's say, go inside a house, right? Let's say you're invited to somewhere, right? There are so many people sitting on a table. If there are so many people sitting, you stand up and address yourself. Okay, hello everyone, my name is this, right? It's the same idea, sending it to 255. You are sending it, broadcasting it to everyone, and the router, the Wi-Fi router is the only one listening, basically. So, and that's the only one responding, right? Because if you see, if you are broadcasting 255 or this very last IP address in a subnet or even in a network, that's how you are talking. That's why broadcast Wi-Fi router is the only one listening at this. As for the link layer, in the first and third packet, the client sends to broadcast MAC address, the last one, not shown in the output above. The DHCP server offers an available IP address along with the network configuration in the DHCP offer. It uses client's destination MAC address. It used the proposed IP address in this example below. Okay, so instead of sending 000, it's using MAC address to send the packet and or attaching the packet. So what is happening is, let me clear this thing quickly. Okay, so what happens is router, when talking, right, is able to get the MAC address, the hard-coded the MAC address of the computer, of the laptop, right? So what does it do? It says, okay, this MAC address will have this IP in the subnet. So let's say if I have a phone, right? There is let's say Rover in the house. There is a Wrench and Sriram. You guys are in the house, right? All of us have our phone, have our laptop. So, but all of the MAC addresses are unique. So it would be, this would be my iPhone, this would be Rover's iPhone, MAC address. Another, let's say, Wrench's IP address. Sure, Samsung, maybe Android. Sure, I'll change it to Android. Right? It will have, let's say, IP 1, 2, 3. So now how things work is, this is the routing table also. I think that's what is the name. So let's say when we are in a house, there is a Wi-Fi router, and let's say my phone is here. My phone is here. This is Rover's phone. And this is Wrench's phone, right? GRW. Now, from the outside world, because this is the gateway, right? Remember, this is like the outside gate. Wi-Fi router is outside gate. It receives all the packet from the internet. Now, it receives the packet with the from outside IP, right? It doesn't know the IP here. What it does know, who IP belongs to, is based on the MAC address. So, router will say, okay, I received a packet and I'll draw like this. Why your phone? I don't know. So outside, right, it received from its public IP address. Now, how will it send? It will send it based on the MAC address. It knows the MAC address of my phone, Rover's phone, Wrench's phone, right? It will look at the my IP address, my MAC address, right? Because the packet has that information, and send it to me. But how? It first look at my MAC address and matches it with the IP with the MAC address from the packet is received from the internet. This is another step that's happening. So just so you guys are aware, right? The DHCP server offers available IP address along with the network configuration the DHCP offer. It uses client's destination MAC address, right, for mapping. It used the proposed IP address in this example system. This thing is the table, router table. At the end of DHCP process, our device would have received all the configuration needed to access the network or even the internet. In particular, we expect that the DHCP server has provided us with the following: the least IP address to access the network resources. Remember, it's the least IP address. Why least? Is because, let's say, if it will always be least. For example, let's say at the coffee shop, right? 1,000+ people. This is a very famous coffee shop here. Very famous coffee shop. Thousands of people every day come, right? Let's say in a week it reaches a traffic of 5,000+ people, right? The Wi-Fi router doesn't have to have 5,000 IP addresses or DHCP mapping done, right? The MAC and IP done, right? It says, okay, I'm going to give you a IP address for 1 day. After 1 day, I will delete it. So it's leased. If you don't come within 1 day, it's not refreshed, it will be deleted. That's why it's a leased IP address. It's not permanent. When you go home after like a vacation and look at your private IP in the subnet, it would always be changed. No guarantee you will have the same unless and until you configure manually. The gateway to route our packets outside the local network. So the gateway is like the Wi-Fi router, the outside gate, so we can send things out of the house. A DNS server to resolve domain names, a Google to its IP address, right? So three things DHCP server, a Wi-Fi router does. IP address gateway provides us a gateway and the DNS server. How many steps does DHCP use to provide network configuration, lads? This is for you. How many steps? So we have DORA, discover, offer, request, and acknowledge. That would be. I need answers, bro. If first thing I first thing in the morning I'm coming is like doing streaming. I need answers, man. Come on. Why is only when it comes to roasting you guys are most active? Hello. Yo, insomnia. I love that 6-7. Holy man. How you doing, insomnia? Dude, yeah, idiot. Like as soon as I saw that Chat GPT meme going, or our next Chat GPT instead of 6, it will be called 5-6, 6-7. I was like, this is stupid. Like things are. I don't know even he posted it or not. But it's like stupid. Wait from 6 to 7 when they learn about 9 to 5. That would be interesting. What is the destination IP address that a client uses when it sends a DHCP discover packet? It's the broadcast address, what it is in the IPv4. I love this 60 idiots say 67. Yes, sir. 255 in all. The broadcast one. What is the source IP address a client uses when trying to get IP network configuration over DHCP? Thank you. Yes, sir. So these are special IP address, right? Everybody starts from 0, and because they are new to the system, they don't know who to contact, where is the Wi-Fi router. So they will just send to the broadcast IP address, and after the configuration is there, they will use the other IP addresses, not these ones. All answers in front of you, but you can't read them. Okay, I see you. I see you, buddy. I see you. Okay, let's see. How big is ARP1? Oh, thank you, man. Thank you so much. Makes my day. Love it. Okay. I'm just thinking, this one, will we be able to cover it in like 15 minutes? Or 10 minutes actually, because I have to leave at 10:30 or 8:30 for work. Network interesting, but I'm stuck in port forwarding. I can explain you port forwarding. Your rent says hi, insomnia. Port forwarding, what exactly you are stuck with port forwarding? You don't understand the concept at all, or how it is? Howdy, Ranch. Howdy. Do you want me to explain to you network forwarding a little bit? SSH tunneling, I can explain you. Oh, you understand it. Okay, good. Because SSH tunneling is a really, really important concept in DevOps in cloud. Oh, I see, I see, I see. What's that? We get is there. Lateral movements and pivoting. Learn about common techniques used to move laterally across a window network. Okay. Okay. We get a stir. I have no idea. Oh, is that a command? Oh, SSH tunneling. Okay. SSH tunnel user IP at attacker IP. Huh. I think I know what this is. Why the double a dash double L? So, quickly here. This is your tunnel, right? This is your tunnel. Yeah, don't worry. Encoded the message so you can't understand. Got it. Okay. So, and we have this quickly. I will decode this. Okay, this will be a quick concept. So we have SSH, right? We are using SSH from here. Let's say R, it's me, to a server, and I'm tunneling because that's the secure way to do it. So this part is covered this using SSH, right? From this port, this is the server. The dash L, the two dash L's. Let's see. I want to. I remember the first two dash L's. Let's see. Let's use ChatGPT. I think it's so maybe because like it's forwarding from not just one side, right? Not only like it's listening from this part, let's say 6666 or port 80. It's not just listening from port 80, goes from here to this port, and also listening from a different port, listening from both side. 1 second. Okay. Nice. Let's try to break down piece by piece and explain exactly how each part does. One remote server tunnel on this. Others that can reach out can connect through your this server. Your two local forwards that makes ports on your local machine available and forward them to the ports to the remote server. Okay. So there are two local forwarding going on basically, yeah. So just to basically two local forwarding going. So from both the addresses, they will be able to reach. That's so anyone connecting from 6666, right? All the IP, all their traffic will be going out of the same port 6666, and same idea with 7878 that if anybody connects from 7878, the stuff will be going out of 7878. Got it. So this means there are two gates almost to this. If this is the server, there will be two gates going from it. Another tunnel. One from like 6666, other from 77878. Okay, we decoded it. Nice. Alrighty. Yo, Insomnia, yes, Wrench is saying hi again and again to you. Okay. But yeah, lads, I think this is it for today because I started late, not going to lie. I was just sleeping. I'm trying to catch up on my sleep. But that was a nice day. At least like we got one down. So for tomorrow, right? Tomorrow we will cover ARP. I know it will take around like half an hour to cover. Then ICMP. Again, I think it should take half an hour because ping and trace route are fun. We can try. Yeah. Sure. Wrench, go for it. Oh, yeah. No problem, bro. Then we have routing and NAT. So I think in 2 days we will be able to cover. Tomorrow we'll cover task 3 and 4, and day after tomorrow we'll cover task 5 and 6. Did you run the game thing? Which game thing? The sponsorship? Oh, yeah. Please download this game and play for 15 minutes. I just have 2 yet. Need more. Yeah, I did run the game. Bro, I don't understand Roblox at all. I'm not going to lie. I just don't understand this game. Yeah. The second person is me, bro. I am the second person. I just didn't like it. It's just like the game interface is not that. Like I just didn't like it. I'm a person who loves GTA Vice City more than like these games. Yeah, you were the first person, 100%. If we are not able to make much, I can just send you the $4. I will say. I'm just thinking because if there is like hardly anybody download, hardly anybody did like anything, man. I just don't understand why. Okay, or whatever. We'll see. We'll see. We'll see. GTA is way good, man. GTA Vice City is like the goat. This is the goat of all time, in my opinion. Like that game, I would play any day of my life. I'll play that game so much. Love it, man. And this car itself is like goated. The story itself is also fucking good, man. Of this game, the story itself, good. It's such a good story. For its time, the how things went, it's so good, man. Even GTA San Andreas was super good for its time. Dude, if you think about like 2000, this is actually like really good for 2000. The graphics are indeed like shit. But for 2002, that's actually really good. I won't say I liked every single one of them though. I won't say I liked every single one of them. I don't think I liked GTA 3 much. 5 was great. 3 was not that good. Mind blowing at the time. Yeah, 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 yeah. Star Fox. Oh, I think I've seen this. I've never played. I think I've just seen this. Yeah, that's nice. GTA San Andreas and GTA 5 is also really good. GTA 5, really good. GTA San Andreas, amazing story. GTA Vice City, amazing story, amazing stuff. 3, not so much. 4, I don't think I have ever even played. What was that other game like you guys showed me, which was a shooter game? Um, Wrench, I think you mentioned that game where it is like we are looking to hit Hitler, right? GoldenEye? Oh, the James one? Yeah. It's similar to this one. There was one you mentioned, I forgot. No, no, not this one. There was one which you mentioned. A guy is basically there's the guy's image in the very bottom. Um, and then we are like looking to kill Hitler. It's similar to this like POV type camera. I forgot the game. Yo, Ghost, what's up, bro? The plan. Thank you, Panda. The plan game. Ooh, this looks cool. What was this about? Oh, the heist. Okay, that's actually like nice. Dude, this looks nice then. There's a heist you have to pull off. No, it was 100% you. I remember this was you, and I was like, oh, that's the name. I loved that game as a kid. It's an old game in 2000, like 5, around that time. I thought it was like Wolfenstein, but it wasn't Wolfenstein. It was something else. Uh, 3 characters control and you need to do heist. That's actually cool for its time. One old. This one, right? Similar to this one, I think. Or it's this one, Wolfenstein. Have you guys played this one? Anyone? Have you guys played this one ever? This was like I think yeah. It was basically a shooter game, but we had to like so many other levels we have to go through stuff, and the story was basically killing Hitler. Nothing much like in terms of mission wise. Basically, what whoever you find, you have to kill. That's pretty much it. It was a good game, man. This one was so good. I loved this game. For its time, at least, it was pretty good. Sure, I will play. Let's play one game of chess. Sure. Let's end the stream with a game of chess. Damn, it's already 20 minutes. I'm late to work. Okay. Panda, do you have. You must have mine. I think we are on. Yeah, here we go, Panda. What's IGI? Oh, it's a shooter game. Okay. Bro, even Hitman is so good. Like, Hitman also had the same graphics. This looks so good. I've never played this one, but it looks so good, man. Holy. Oh, there's 2023. Nice. That one was OG. Oh, I think I've seen this specific image couple of times with this gun. Yeah. Damn, that's cool. Oh, accepting. Okay. Alrighty, lads. Let's see. Watch me. How good I am. Panda, accept it. Oh, if I lose 24? What the hell? If I win, I get 8. I draw, I lose 8 points. And if I lose 24 points. Wolfenstein 3D. Oh, okay. Yeah, yeah, 19. Yeah. Panda, where you at? Okay, let's see. So won't lose 24 unless you play super bad. Bro, no, like how usually the game happens with the points here is if I lose, I should lose only 8 points, draw 0 points should be taken out, right? Like, but in this case, because I have such a higher rank than Panda, this one 1 to 1 compared to 10-30, that's why I will be like losing a lot more. Chess, mate, chess. Why did that? My brain lagged. My brain just lagged. Why did that? I fucking lost already. Yeah, yeah. Dude, my brain lagged for a second here. Ah. Yeah, basically. Illo illo. What is oh, is Panda still thinking? You're still there, right, Panda? The one no one is there anymore. Oh, where? Okay. Oh, okay. Hmm. Damn, it it I hate the GitHub API too much. Oh, it rate limited. Okay. पहले एक ये मूव करूँ इसको यहाँ से हटाऊं। Oh, good one, Panda. Good one. Good one, Panda. Good one. Why? Why you did that one? What? Why? Why that move? Oh no, I fucked up. Oh, you got distracted? I understand that this one was a mistake too. So I understand, buddy. Oh, gotcha. No, it was a mistake. I'll tell you why. There was a very better move I had. Way more better. It can be a good move, it can be a really bad move. Bro, I would love to just play chess one day in the stream. That's all I want to do. Fucking hell. I want to end the game fast. And I don't want to lose. Okay, a game over. Let's think. This is GG's right here. And until I do something really dumb. This is GG's right here. Yeah, yeah. Dude, this is not fun. It's trying to get stalemate from me. Can't do it now. Oh, good try, Panda. Okay. Bro, I made so many mistakes in that one. Two misses. Yep. I made so many mistakes in that one. I think Panda was distracted. Yeah, Panda was distracted, and I also like made so many mistakes. Holy. Well, alrighty, lads. Yeah, I know. Too many blunders I've reported. Oh, it's, I guess, part of the game. Makes sense, Panda. No, I know you were busy. I know you mentioned that before stream. Okay, lads. Sounds good. Yeah, we'll do on the weekend, we'll do a chess round. But thank you so much, lads. Hope you guys have a great night, have a great day. I will see you guys tomorrow, and tomorrow we will cover task 3 and 4 of Try Hack Me. Till then, thank you. Bye, and a big wait. Yeah, your DSCP, Mr. This is your favorite DSCP protocol on Twitch, on YouTube. The sniffer of neighborhood sniffer of packets, especially when they're in a straight line. Thank you. Have a good one and a big bye. Have a good one, lads. Love you. Thank you for coming. Bye. That's what she said.